Hey everybody, welcome back to the channel. Thanks for watching. Today I'm going to be diving into TypeScript, a language that is near and dear to my heart. Now, I am not a fanboy of much, but I like to think of myself as a practical about the tools and technologies I use. You know, what's good today might not be great tomorrow, but I am a fanboy of TypeScript. I mean, I love it. I really think it is the way to write JavaScript code, and I'm here to convince you of that too. I'll even show you how to use TypeScript in regular old JavaScript. So as always, my goal is to have you leaving here ready to go and start using this stuff on your current project. Although today is a little different since this is actually going to be a two-parter. In this video, I'm going to introduce you to the concepts and syntax of TypeScript. And in the next video, I'm going to show you how to take an existing JavaScript application and convert it to TypeScript. So grab a seat, get comfortable, and let's jump right in. Also, if you like what you see, don't forget to hit that subscribe button and join our wonderful community. All right, now let's get started. First of all, we'll talk about TypeScript. What is it? It's a superset of JavaScript that adds static type syntax. It was created and released by Microsoft in 2012. You can go to typescriptlang.org to look at all the docs, and they even have a cool playground in there that you can actually play with the language in your browser without downloading and installing anything. And so I actually heard about TypeScript back in 2012 when it was released, and my initial reaction was, I really love JavaScript, right? I love the dynamic nature of it. I love that I can kind of create objects and assign different stuff to them, create properties dynamically. You know, I really loved the dynamic nature of JavaScript. I also spent a dozen years on C#, statically typed language, where you have to write a couple dozen lines of code just to get a hello world happening, right? As opposed to, you know, one line in JavaScript. So I really was skeptical, and I said, you know what? I respectfully decline to use your language. I'm going to stay with my JavaScript. Thank you very much. And I went on like that happily for a year or so until I actually came back to TypeScript because I realized we're not actually breaking anything. TypeScript doesn't change JavaScript. It actually just adds on to it. So what do I mean by that? Really, what do we mean by static typing? So in order to understand what TypeScript adds, we have to understand the difference between dynamic typing, which is what JavaScript uses natively, and static typing. So with dynamic typing, you can create a variable, you can assign it to, let's say, a string value, and then just go ahead and reassign that to a numeric value, and then just go ahead and reassign it to something else. So on line 4 on the left, we're just assigning it to some variable in the window somewhere, some global variable. I don't know. We've never seen it before, but I'm assigning it, and it's totally cool, right? In a dynamic language and a dynamic runtime, all of this, totally cool. Now, in a static runtime, not cool. You have to define your type, and once you define that type, it stays that type forever. So you create a string-typed variable, you try to assign it to a numeric value. Nope, that's a compile time error. And with a static runtime, that is also a runtime error. And that is the huge difference between TypeScript and JavaScript. Even when you use TypeScript and you add static typing and you get those errors when you're developing, the first thing you do is you take that TypeScript code and you transpile it to JavaScript. The first step of that, rip out all of that type information that you just gave, throw it away. And what you're left with is JavaScript. Dynamic, beautiful JavaScript that runs on the dynamic runtime. So you're never running in a static runtime. You're always still running in that dynamic JavaScript runtime. So if we're always running in a dynamic JavaScript runtime, why are we using static typing? Well, these are kind of in reverse order for me, by the way. So the least important for me is that you're catching more errors earlier. You're catching things like mistyping. You're catching things like I mentioned earlier, you know, passing in a string value when you're expecting a numeric value in a function call or something like that, right? You're also getting better tooling. So you're getting IntelliSense, is what VS Code and Visual Studio call it. You know, the things like autocomplete and type ahead and stuff like that. You're also getting better refactoring. So let's say you have a class with a property called name on it, and you want to rename that property to, let's say, username. What are you going to do in JavaScript? You're going to do a global search and replace for name. Good luck with that, right? What could go wrong? But with TypeScript, TypeScript knows every single reference to that property throughout your entire code base. And so you just click on it, say rename. It renames all those references. You're all good. No errors, right? And finally, we have that documentation. So perhaps the most important thing that TypeScript gives you is documentation. So once your code is written and is living on, and some other developer, might be you, comes back in a couple years and looks at it, it is very clear how your application works. What data you were expecting from that API call you made, what data you're expecting to pass between functions, what return type those functions give. All of that is very well documented for everybody to just dive in and understand. So JS doc types. Let's talk about this for a second. This slide is very specifically and deliberately targeted to all the people who say, I don't want to convert my existing JavaScript code to TypeScript, or I have a small JavaScript application, right? It's 1 or 2 files of JavaScript, maybe a couple hundred lines of JavaScript code. I don't want to add TypeScript and everything to that. I just want to keep using JavaScript. Well, guess what? You can. And you do it by using JS doc comments. So as you can see here, like on line 1, I'm saying the type of my var is string, right? And then on the following lines, I use comments on top of a function to describe the parameter values or the parameter types and even the return value of that function. And the best part of this is that it gives that IDE more information, so you can get that. You don't usually get refactoring as much with the JS doc comments, but you at least get that error checking. You get that autocomplete type ahead, but you get that documentation, right? Most importantly, you get that documentation literally in comments right here. But the best part here, this is a .js file. This is pure JavaScript. Because it's comments, it will still run in your browser. It'll run in your Node applications as is. What we're looking at on the screen will run, right? You don't need to go through that transpiling step. All right, so now that that's out of the way, let's talk about TypeScript. What is the basic syntax? Well, the basic syntax is nothing, right? And the reason that I have this slide in here is not to trick you, but to talk about how powerful TypeScript's inference is. So just by looking at your code, TypeScript says, because you've initialized this variable with a string type, then this variable is a string type. And so if you try to assign it a numeric value, that is a compile time error. Now, if you actually want to say explicitly what the type is, this is the syntax. It's colon and then the type. So in here, I'm defining a variable age and giving it the type number. Here's a function definition here, right? So same syntax, just a little more complicated here. Now, we've got 2 parameters. The first parameter is name, and it takes a string type. The second parameter is date, and it takes a date type. We also have that question mark. I'm going to get back to that in a second. We're going to skip ahead to the end, to the return type. This is the return value. So we're saying this function returns a string or undefined. Now, this is actually a union type. I'll talk about that in a little bit, but you can read this as it returns a string or undefined value. Now, when we as humans look at this code, we can tell there's no way it's ever going to return an undefined value, right? We're returning a string. It's always going to be a string. But when I apply this return value here, what I'm doing is I'm basically defining that contract, and I'm saying, well, I reserve the right to, at some point in the future, return an undefined value. More importantly, the consumers of this function need to take that into account. They need to check the return to make sure they got something and it wasn't undefined. All right, now let's jump back to that question mark there. So that question mark says that this is an optional parameter. So going back to that idea that JavaScript is beautiful because you can create functions with a dozen parameters and then call those functions with no parameters. And the types of those parameters, the values of those parameters are undefined at runtime, right? So TypeScript helps you meet in the middle, right? So here I'm defining a function that has 2 parameters. The first one is name. It's a string type, and you gotta pass it. But it has this second parameter that says, you don't have to give any more parameters other than that first one. But if you do, this second one needs to be a date value. So it's optional. But if you give it, it's got to be a date. And likewise, TypeScript is smart enough to look at this code and say, okay, this could possibly be undefined. Because it's optional, it can be undefined, and I actually have to take that into account in my code inside of this function. So I'll, maybe wrap it and, default to today's date or something like that in this instance. And then we're all good. So the real power of TypeScript is where you can define your own custom types, right? All of the out-of-the-box types, they're great and they're helpful and they get you so far, but the real value is defining your custom types. So the basic syntax for that, the basic building blocks of a custom type is going to be an interface. So here I'm using this syntax to create an interface called person. That interface has two properties, one called name, that's a string type, one called age, that's a number. And so any objects that I apply this type to must adhere to this interface, this contract. Also, if I try to assign it to something that doesn't, I will get an exception, right? So here I've tried to assign it to an object that doesn't have that name property. That's an error. It's missing. If I give it that name property with a numeric value, everybody's cool. Now, what if I want to pass in an object without that age property? Well, I can bring back that question mark operator there, and I can make that property optional. So just like I made a function parameter optional, I can use that question mark and make a property optional. And so that that first example works great. Likewise, if I try and give it that property and give it that value, it has to be a number, right? So I don't always have to give it, but if I do give it, it needs to be that type. In this case, a number, and I try and give it a string. That doesn't work, not assignable. We can also extend interfaces, right? So here on line 7, interface employee extends person. So basically I'm defining a new type that takes on all of the properties of that base type that I'm extending and then adds more. So I'm taking all of the properties of person, and I'm adding on a new property called title with a string type. Now, union types. I talked about that pipe operator before on that return value. Here, I'm not deriving from anything. I'm not extending any types. I've got two different types, person and employee. And then all the way down at the bottom on line 13, I'm using that pipe operator to do a union of these two. So I'm saying let the user variable be type of person or employee. That's what I like to say, or employee, right? So I can pass in a person or employee. That's how you can think of it, but that's not actually what happens. At runtime, what actually happens is it takes the intersection of those two interfaces. Two in this example, you can add as many as you want. Pipe Boolean, pipe date, pipe whatever, right? This is just two in this example. So in this example, user will actually be an object that has a name and a create date. Now, going back to that idea of how smart TypeScript is and the TypeScript inference and how TypeScript analyzes all of your code. If I create that same union type and then I go and I say, well, if title is in user, in other words, if the user object at runtime has the property title, then do something, right? Else, so in this else condition, if you look at this IntelliSense, the autocomplete that I'm offered here, it's showing age. And if we look over here, we see this is a person. If it has a title property, therefore it is an employee in this block. Otherwise, if it's not that, it must be a person in this second block. And a person has an age. So you get that full autocomplete type safety in there, but it's actually determined that you are a person. All right, next up, aliases. So where are aliases valuable? We have two functions here, right? Both of them accept a date object that can be a string or a number or a date, right? So this would be familiar if you've used that date constructor before. Then I'm passing that to another function which has that same value, string or number or date. I'm repeating this over and over again. So in development, we don't like to repeat ourselves, so I'm going to create an alias for these three things, for this union type that I made. And I'm going to use the type keyword to do that. I'm going to say type date-like. I can't call it date because that's already taken by the actual date type. Date-like equals string or number or date. And then I can go in all of those instances where I've referenced that, replace them with this new alias that I've made, and there you go. This also allows us to go back to that dynamic nature of JavaScript, right? So the awesome thing about JavaScript is you can create a variable, initialize it with a string type, you can reassign it to a numeric type, you can reassign it to a date type, whatever you want, right? So with aliases and these union types, mixing them like this, we're going back to that dynamic nature, but we're still giving those guardrails. You can assign it to whatever you want as long as whatever you want is a string or number or date. Can't assign it to literally anything. That's still a compile time error. All right, so now what you will see a lot, there's a big debate about interfaces versus aliases. When do you use them? And so technically speaking, you can use aliases to define data structures, right? Like this. Should you? My opinion is to use interfaces to define data structures like a person, right? And then use aliases to define or derive complex types like those union types, or you can derive types from other types. So I give an example down here that I don't expect you to understand now, but we're going to learn about that in a minute. Let's talk about generics first before we get into that. So here, if you've never dealt with generics in other statically typed languages like C#, which, by the way, the creator of C#, also the creator of TypeScript, so you're going to see a lot of similarities between the syntaxes. Here I have a generic function called print array of type T. So we have those open bracket, close bracket. The way we read this is of type T, right? And then this accepts one parameter, an array of type T. What is type T? I don't know. I haven't defined it at development time. I really only do it later, right? Runtime, right? I can reuse this in a variety of situations. And in this case, the code I'm showing, I'm passing these items to console.log, which will take pretty much anything and log it out. So it doesn't really matter. So I can give it an array of numbers types, totally fine. I can give it an array of strings, totally fine. Everything's good. Now, if I change line 7 and I explicitly define the type of T as string, and then I try and pass in an array of numbers, that is a compile time error. You can also narrow down the types that are allowed to be passed in by using that extends keyword. So here I'm using extends, and I'm passing in a union, person or employee. So in other words, print username of type T, where T extends person or employee. You can only give a person or employee as type T. And again, remember what that union type means. We only have the intersection of those types. So in our case before, name and create date are available in the code inside of this function, this scope. So if I try and pass an array of numbers, that's a failure. They don't extend person or employee. But if I pass in a person type and an employee type, the function's totally cool. We're all good. All right, now key of. Let's move on to key of. This is perhaps the coolest thing, or maybe the second coolest. I'll show you another cool feature later. So key of is like a meta keyword. What key of means is that you can take all of the properties of a type, and that is the values of your type. It basically creates a union of the property names. What does that mean? Well, let's look at code. So it's a lot easier to look at code and see this, right? So I have type person fields equals key of person. And the names of the properties on person are name, create date, and age. And you can see that when I use autocomplete here, the autocomplete suggestions for the string values that are available to assign to this variable are age, create date, and name. String values. Likewise, if I were to add more properties, remove properties, rename properties, that would also change the options that are available here. This might blow your mind a little bit. So I'm going to talk very slowly so you can read all of this and kind of take it in. I'm combining all of these things that we just talked about over the past couple minutes. So up top, I've got sort users by type of. I've got two generic types I'm passing in. Type of T user, which extends user. In other words, let's just say that's an alias for the union type of person employee, like we saw before. And then the second generic parameter is T field extends key of T user. Then you can see on line 2, the first parameter is array of T users. The second parameter is T field, which means the second parameter is the name of the properties on T user. What does all that mean? Well, look at the autocomplete down there, right? All of this comes into play where I can give an array of users for that first parameter, and that second parameter is the string name of the property. So in this case, I'm sorting this array by a property, by a field on those users, right? And so I want to sort by create date, or I want to sort on name. And because I'm passing in a list of person or employees, those are the two options that I have available to me. So key of is really, really powerful, especially when you use it like this in a generic sense where you're actually extending off some other generic parameter. All right, now let's talk about utility types. So JavaScript has a bunch of generic types that are built into the library, come in your TypeScript definitions right out of the box. This is like a list of a little over half of them, maybe, that are available, at least in 2024. Pretty much the most widely used ones, the most commonly used ones. So I'm not going to go through all of these, but let's pick out a couple that I use on pretty much a daily basis. So the first one is partial of T. It simply marks all properties of type T as optional, right? So we talked before, I showed how to make an individual property optional by using that question mark. But this actually takes all of those properties, makes them optional. So we can see we have the same net effect, right? I've given a type down here with just the name property, totally cool. Now, next up, we have required of T. So this is the opposite, basically, of partial. It takes all of those properties of type T and marks them as not optional. If they are optional, it rips that off. So here we've got that one that we ended up with before, where we have that optional parameter age. If we wrap it in a required of type person on line 6, we see the age is now required. Next, we have omit T and U. Omit type T and type U. It omits all properties of type U from type T. That's kind of a mouthful, so let's look at the example. On line 7, we omit from type person the properties name or create date. So that's a union of all of the property names that we want to strip off, kind of like key of, right? We want to strip off all of those properties. So what we're going to be left with is just a type that just has an optional age property after that, right? So you can see now if I'm trying to assign a value of, name is Alice, then that's not available. Object literal may only specify known properties, and name does not exist on this type that you've defined. All right, next up we've got record T and U. Defines an object with field names of type T and properties of type U. So this one is kind of a weird one to wrap your head around. And I strongly urge you to actually see this in action in my next video when I convert my JavaScript application to TypeScript and I show this in action. It makes a whole lot more sense in action. But what the net result of this means is that we're creating a new type. All of the available property names of that type are in that list of that type T, that first generic parameter. So in this example, validation fields are either name and create date. And the second parameter, in this case Boolean, is the value or the type that all of those properties must have, all of them. So this creates an object with two properties, name and create date, and the types of both of those properties are Boolean. And you can see here, I'm trying to assign that string value test to the create date property. That's not assignable to type Boolean. Likewise, it requires all of those fields to be present. So if I say I need a record of name and create date, but I only give it a name, even though I've assigned it a Boolean property for that name, it is not valid because it's missing that create date property. Thank you so much for watching. I hope you found this helpful. And remember, this is just the beginning. Stay tuned for the next video where I'm going to put these concepts into action and get to the really exciting stuff, which is converting an existing JavaScript application into TypeScript. So in that video, I'll walk you through each step and I'll talk about some common pitfalls and best practices so you can make your transition smoothly. And remember, if you liked this video and want to see more of this to take your skills to the next level, be sure to like and subscribe so you don't miss any of my new content. Until next time, see you later.